Okay. Chapter 9 and chapter 10 will cover very important concept of inference statistics. Um, Recall in the chapter 1, we talked about this figure right here. From the population, we draw a sample. And with the sample, we describe the data fed using numbers and graphs. So chapter 2 covers all different kind of graphs, and chapter 3 covers numbers, what kind of descriptive, numeric descriptive statistics that we can use to describe our data. Now we are actually closing this cycle by making meaningful inferences here with this step. In other words, we'll make a generalization about the population based on the sample. Depending on how you want to make inferences, you can estimate the parameter or do hypothesis tests on the parameter. Chapter 9 will focus on estimation, and chapter 10 will focus on hypothesis testing. Chapter 11 is an extension of estimation and hypothesis test for slightly different structure of the question, but a similar concept will be continuously used um, after chapter 10 and moving on. Okay, so often you will read an article like this. The poll found 51% think tax cut for the wealthy would hurt the economy compared with 23% who thought it would not. It would help. Also, 48% said tax cut for the large corporations would hurt the economy compared to 31% who thinks they would help. Blah, blah, blah. The poll is based on 1,054 adults and at the end, it says the margin of sampling error for all respondents is plus or minus 4.0 percentage point. So there's a lot going on, but let's just kind of think about a couple of things here. So we know that our actual data fit is based on 1,054 adults, and then based on that sample, the poll found that 51% thinks tax cut for the wealthy would hurt the economy. And there are other information, but let's just focus on this 51%. Where uh, this 51% coming from? Is this population proportion or sample proportion? It is a sample proportion, right? Out of 1,054, about 538 people responded that they think the tax cuts for the wealthy would hurt the economy. So, in fact, 51% um, is pretty much 538 over 1,054. And this is an estimate of the population proportion. So we really don't know the population proportion, which means, for the entire American population. However, based on our 1,054 sample, we come up with this estimate, which is 51%. And that's actually a very basic idea of estimate. Margin of error. So if you look at the sentence at the end, it says something about margin of error. Margin of error is another important term that we will learn in this chapter. Depending on how large the margin of error, we'll have an idea how accurate this estimation is. For example, if our margin of error here is 30%, then the true proportion can be anywhere between the 51 minus 30, 51 plus 30, which is 21% and 81%, which really doesn't give us clear idea about whether people think this way or other way, because 81% and 21%, it can be anywhere. In this particular example with our data set, it says that the margin of error is 4%, meaning that the true proportion is somewhere around 47% and 55%. So it actually has a little bit of a tighter um, uh, guess. So, our 51% is not really too bad of estimate. So, this margin of error, and then it actually depend on the question. But anyway, this margin of error term actually gave us those kind of ideas, how accurate our estimate is. Um, Other thing I want to show you is to visually show you this concept. I'll show you an interesting website called StatKey. So I'm gonna get out of here, and then here I will just put the stat key. Then the very first one is called Stacky Lock 5. So I'm just gonna click that. And one of the options, since we're actually talking about confidence intervals or estimate for a single proportion, there are a lot of the complicated concept that um, I'm gonna actually push the button, but not necessarily explain all the details. But it's okay. I just want you to actually visually see what's happening with the estimation. So anyway, so I'm gonna click that one. And then there's some random data about the mixed nuts, but we're going to actually use the data set we were talking about with the text cut. So our data set, I'm just changing the data set to our current data set, the 538 out of 1054, right? That was our data set. So typically, if you're dealing with a real data set, your data set probably will look like that. If you click OK, and we'll say that on the right-hand side, there's a summary information. The count is 538, whole sample size is 1054. So your proportion estimate is 0.510. So for that's a kind of point estimate, but we want to actually know how confident that are for with the margin of error. So what it does here is it does kind of come up with some sampling distribution based on something called bootstrap sampling. So what it does is if you actually click generate one sample, they just put those 1054 sample all put together and then select another 1054 samples, but the difference is with replacement. So they pick one and then put it back, put one number, yes or no, I guess, agree or disagree, which you'll count as count or not, and then put it back and take it out and so on and so on, 1054 times. For the first 50, the first sample, first 1054 sample, this time the count, yes, was 558 times compared to 538 times. So our proportion is 0.529. So it's slightly different. So you can do this whole bunch of times. Or if you do like thousands of times, what it does is it will generate hypothetical, or we call it this part, the bootstrap empirical distribution of the proportion that we can come up with. Then uh, this, if you click the two tail, it will automatically gives us some range of it. So the proportion that we are considering, the text cut, what was that story? The 51% tax thinks that the tax cut for the wealthy would hurt the economy. So here's another our 0.51. This one is plus minus margin of error, right? So that was our margin of error. So here it looks like for based on that, our margin of error is about 0.03-ish. Okay, so that will be our margin of error look like. And then those two are actually, we call that confidence interval for our population. Again, this middle number will be your one number. We call that point estimate. And then these two number will be kind of interval estimate. Again, you don't need to worry about the concept of bootstrapping, not quite yet, but I just want to show you that this is the somewhat arbitrary, well, not arbitrary, distribution, based on empirical bootstrap distribution here. And then based on that, we can come up with a confidence interval. So chapter 9 will be pretty much talking about this guy, what's the point estimate, and how we can calculate confidence interval, and how we're going to interpret those numbers for both proportion case and the mean case.